Still spinning around in circles? What if I told you that mastering circle theorems is as easy as To become a Circle Theorems Pro in just minutes, it is essential to focus on some key techniques. That is, understanding the relationship among the radius, diameter, and circumference of the circle. This simple yet powerful step-by-step guide can help you to master various tasks involving the circle, from drawing to simple calculations. By grasping these fundamental principles, you can dramatically improve your understanding and skills as it relates to solving problems around the circle in the shortest amount of time. So, come with me now and let's explore what circle theorems is all about. Circle theorems are properties that shows the relationship between angles within the geometry of a circle. Very important to understand the word there, within. So we're looking basically at what is relationship among the angles within the circle. So in order for us to access this topic, we must first of all know all the parts of a circle. So I've just put this here as a prerequisite skill to help you to understand this. These usually show up as 1 markers on our papers. And remember, the difference between 2 grade boundaries is 1 mark. Lots of students will tell you that I'm off a grade 9 by 2 marks, or I'm off a grade by 1 mark. So let's make sure that we know this. So I've animated this here just to make sure that you focus on the part that I'm dealing with as we go along. So first of all, I'm looking at the region all the way around the circle here. So I've listed the words here also that you can match them up. So the first one, A, distance around our circle, is our circumference. Now we're going to look at part B. So I've indicated that there, put a little bit of twist to that. So part B is our chord. So the chord here connects 2 parts of the circumference, but it does not pass through the center of the circle. We then go on to C, and C here is our radius. And the radius, as you can see here, starts from the center of the circle, touching any part on the circumference, and this could be oriented anyway. So a circle basically have infinite number of radii. And then we go on to D. So the highlighted bit here that's shaded is what's in focus for D. So this is a segment of the circle. Now if you're asked to identify, like for example, a definition of what a segment is, do not try to memorize the definition. Simply look at what you have and describe it, because I can see here that this is a chord. So to define a segment, I could simply say a segment is a part of a circle bounded by a chord, and you can see this part also, which we'll come to later, an arc. That's a simple definition there. Next we look at E, which is the center of our circle. Very important there. We also have the part, a slice of a pizza. I know lots of you students love to have your pizza. So it's very important to speak the mathematical language to your friends so that these become permanent in your memory. So rather than saying, can I have a piece of your pizza? Why not try saying, may I have a sector of that pizza? Come on, let's speak the language. So then, F is our tangent, which is this line touching the circumference of your circle. And G, as I said, is your sector, the slice of pizza. Then I've got H, which is our diameter. Now the prefix di indicates 2. So it means 2 measured. So if I go from the center of my circle, going this way, I can see that's a radius. And then going the other way, it's also a radius. So that's where the word diameter comes from. 1 measure going here, one going there, so hence 2 measured, so diameter. So I can see the connection here is that 2 radii makes a diameter, very important. And finally, I'm just looking at this part of the circumference, which is called the arc. So an arc is just a part of the circumference. We could have a minor arc and a major arc. So you can see here, the part I've highlighted here is small compared to the circumference of the circle, which makes this a minor arc. And then the other part of the circle would now be a major arc. Now, with that foundation of the parts of the circle being laid, we are now ready to go into our lesson. So we're going to be looking, this is also the first lesson in a series where we're going to explore all of the circle theorems. And I find circle theorems is problematic for a lot of people, but with simply clear steps, and we're going to be practicing questions 1 theorem at a time. And that's going to change your game. So let's go. We're going to look at rule number 1. Rule number 1 says that angles in a semicircle, which is half of a circle, is always equal to 90 degrees. So I'm just going to ask you to write this down. Now, how do I know I've got a semicircle? I must have a diameter present. So here I've written for you, a triangle drawn from 2 ends of a diameter will always make an angle of 90 degrees where it hits the edge of the circle, and orientation doesn't matter. It doesn't matter where it hits. Once the 2 sides come off the diameter hitting the edge of the circle, then the angle is going to be 90 degrees. So let us visualize this diagrammatically now. So here I've got a circle. I can see visibly. Now, clarification here before we even start. Do not make an assumption that you've got a diameter unless a center is visible or stated to be 0, to be O, using an O. You cannot just look at a line drawn looking to be through the center. You're not sure. Do not make that assumption. So it has to pass through the center for it to be a diameter. Now I'm going to construct a triangle from both ends of the diameter. Here we have it. Now when this happens, the angle here will always be 90 degrees. Very important concept. Now, as I've said before, the orientation doesn't matter. Now, one of the things I find, sometimes looking on a question at a face-to-face angle, you're not able to identify your theorems. Do not be afraid to turn your paper, rotate your paper, and look at your question from different angles. This will help you to see what you are given. So I've put some other orientations here. So it could be that way that the triangle is drawn. We could also have a vertical diameter, which means our angle would be oriented towards this way. It could also be to the right. Now, I've also just put some other ways that it could be. But the important concept is that must come off the ends of a diameter, and where it hits, it will be 90 degrees. You pause the video, you draw a few examples down, and then we're going to practice what does exam style question look like on this particular theorem. So here, we're asked to find the value of x in this question. Now, we are told specifically to give reasons for our answer. Now, as an examiner, I know that sometimes, even though the question doesn't explicitly say give a reason for your answer, there are hidden marks for your reasons. So what I would advise you to do, always give a reason whether or not the question says so. So in this question, we're given a triangle with 36 and we're asked to find x. And we know we need at least 2 angles in a triangle in order for us to find the missing angle. So I'm going to help you to think in a logical sequence here. How do you unlock this question? You need to be asking yourself this question. Now, I know that I need to have 2 angles. How will I know the other missing angle? this is where your theorem comes into place. So because I know that angles in a semicircle creates that right angle, I can fill that missing angle in. So step one, my first reason is my theorem. You must speak the language of your theorem, because that's what examiners look for. So the first reason, angle in a semicircle, I'm going ahead and also always write on your diagram. What that does, it helps to close your gaps. You can now see into perspective what it is that you have and what's missing. So now I've got my two angles. I now need to ask myself, what other reason will I now use to unlock the other part of the question? And the second reason is angles in a triangle add up to 180 degrees. Now, with all of that being laid out, you are now ready to tackle, to put the inking behind your thinking. So, I have two approaches now to calculate the value of x. I can either reason that the angles in a triangle add to 180 degrees, and for your first method mark, you now need to write that equation. So I'm going to do x add 36 degrees add 90 degrees should be equal to 180 degrees. But because I knew that one angle was 90 degrees, I could also have chosen to make my calculation a little bit simpler by just deducing that x add 36 then should be equal to 90, since one angle is already 90 degrees. And that makes my calculation so much simpler. So I'm just going to do that. Now, make sure you have your calculator. I must pause to say, having your mathematical equipment makes your learning process so much smoother. Your teacher doesn't have to be going around trying to find equipment to give everyone and throw off the pace of your lesson. Come to your class prepared. So you need to have your calculator now. So we're going to enter into our calculator. Work along with me. So we're just going to do 90 take away 36. And the answer is equal to, so x is equal to, so just going to write it here, x will be equal to 90, take away 36, and then the answer is 54 degrees. Well done. And you could also prove your answer by just adding 54 plus 36 should get you back to 90. So now we've put our first theorem in practice. So we're going to do one more question before going on to our next theorem. So in this question, we're asked now on this diagram to find the value of y. Now, one of the things that we need to make sure of is that all the topics we have learned, we are looking for opportunities to apply them. Now, when I was a student, that was one of the disconnects for me. My teacher didn't really let me know that even though I'm doing this topic, anything I've learned in any other topic across maths, once I see where it can be applied, it's okay to do that. And I've said that here because we're going to now need to draw on angles on a straight line, angles around a point, all the things you have already learned. So here we are asked to find y. We can see here that all of this angle is 21. And again, in order for us to find an angle in a triangle, we need at least 2. So we need to ask ourselves, what other skill, apart from the theorem, do I need to apply here? So if you see, first reason I'm going to be given is that angles on a straight line add to 180 degrees. So I can use that to find this missing angle, which will be a part of the puzzle that I need to finish the question. So therefore, I'm going to just write an equation. I'm just going to call this one x just to avoid confusions with my variables. So I know then that x plus 121 should be equal to 180 degrees. And again, get your calculator. We're now going to enter that. So we need to do x equal to 180, take away 121. So 180 take away 121 gives us 59. So x is equal to 59 degrees. And again, you put that on your diagram. We are closing our gaps. Awesome. And then we have found a part of our answer. However, we need 2 angles. And I only have 1 and y. Now, my second reason, I hope you thought that. So the second reason is the rule that we've just learned. We know that the angles in a semicircle is equal to 90 because this angle is formed of the ends of the diameter. So we fill that in, that's 90 degrees. And again, this time we need one more rule. Now we've got our two angles. The other rule is angles in a triangle add to 180 degrees. Also, from the example we did before, we can see here, we could also just subtract 59 from 90. Since we know this angle is already 90 degrees, the other two also has to add. You can see here, we don't have to use angles adding up to 180. Whatever it is, you can use that. All right, so I'm just going to make it simpler. So instead of doing the 180, though I've written it here, I'm just going to go ahead and do we need y this time. So y add 59 needs to be equal to 90 degrees. Two sets of 90s make 180. Again, use your calculator in an exam. Doesn't matter how simple the question look. Remember, you are under pressure. So use your calculator. So I'm going to do 90 minus 59. And the answer is y equal to 31 degrees. Fantastic. See, it's not as difficult as you thought it was. Not at all. Now, we're going to be moving into looking at another theorem. But remember our mission. We want to reach as many students as we can. Thank you for sharing to your friends, but let's keep sharing. And also, let me just check. Did you remember to subscribe? Subscribe. I know when the content gets so sweet and you are having a good flow, you forget all about your subscription. But remember, subscribe. Hit your notification bell. Do that right now and send the link to a friend so that they benefit as well. So, with that being said, let's get into rule number 2. So, rule number 2 says that angle at the center is twice the angle at the circumference. Now, you would recognize here that it was very important for us to have known about the parts of the circle. In the first example, we spoke about the diameter. So if you didn't know that, you couldn't access the question. Also here, we're talking about the center of the circle, which we explored, and also the circumference. So very important to learn that. Now, within the same segment, very important information here. Again, we looked also at the key vocab segment. So within the same segment, the angle made at the center of the circle is going to be exactly 2 times as much as the angle formed by the same chord at the edge of the circle. See, I've highlighted and underlined key points for you to focus on. So now we're going to look at what that looks like. I know it sounds complex with all these words, but really, let's visualize it. So again, imagine that I've got this circle here. If I draw a triangle within that circle and I make another triangle from the same chord, so I'm just going to highlight the chord here. I've got this chord at the bottom. If you notice here, both triangles are made from the same chord. When that happens, the angle at the center will always be 2 times the angle at the edge of the circumference. Now, this only comes into focus if they are drawn off the same chord, and they must be in the same segment. So this here is a minor segment, very small one at the bottom, and above the chord is a larger segment, so both angles are within that side of the segment. So that means they fit the criteria. Now again, orientation is quite important. You will not always see it look upright. It could also be oriented this way. Same principle apply. Again, turn your paper around. People might be wondering, why is she turning her paper? You have received some little tricks and nuggets that helps you. Now, another orientation could be that way. Very important to note. Now we're going to look at what the exam style questions look like around this theorem. So here I am asked to find the value of x, and I'm also asked to give reasons for my answer. I've just put the reasons here, just give you that learning frame where you can now apply the concept. So my first question is angles around a point. Now, very key point here. Not all questions will come with the chord being visible. You have got to be vigilant, and you sometimes have to put your chord in, and this is a very, very good example of that. So if you look here now, I'm going to put my chord in for myself, because now I can see that this one here is the angle at the center. I know some people would have run off and say, okay, 240 needs to be divided by 2 to get x. Incorrect. The angle that's actually at the center is actually the one that is on the other side. So if I visualize my chord, I will see that this triangle comes off the chord, and the larger triangle also comes off the same chord, which means those two angles, the one at the center, one on the circumference, they are on the same side of the segment. So I'm going to have to now use angles around a point in order to calculate the missing angle here. I'm just going to call it y to give it some perspective. So I know angles around a point add to 360 degrees, which means that I can deduce that y add 240 should be equal to 260 degrees. And then I need to do the inverse of my operation. So I'm going to subtract 240 from 360. We could do that mentally. However, I would say take advantage of opportunities to use your calculator. So I need to do 360, and I'm going to subtract 240. I'm going to put that in my calculator for accuracy, because even making your video, I would be under more pressure. And I'm trying to make a connection with you, because now in exam you will be under pressure. All right, so y then would be equal to 120 degrees. Again, I put that on my diagram. Now I need to use my theorem. So my theorem tells me that the angle at the center will always be twice the one on the circumference. So that means x then has to be half of 120 degrees. So I need to divide that. That one is simple, so we don't have to put that in our calculator. However, we can check afterwards we've done it mentally, because we also need to build our mental skills. So 12 divided by 2 is 6. So this answer is going to now be 60 degrees. And I can check. I know the smaller angle has to be the one on the circumference. So we have another question to do that relies on a little bit more application as well, similar to the ones we did before. So here I'm asked this time to find the value of y, and also to give reasons for my answer. And again, I've just given you that framework. So we are going to first of all recognize that we don't know the first angle at the top, and we do not know the one at the center. But guess what? We've learned enough mathematical skills to just simply solve that problem. So again, I'm going to visualize my chord here so that I can see that this angle is my angle at the center, and then I'm going to apply my knowledge of angles on a straight line. Now again, this is a very simple one, the fact that we've got 100. So clearly, once I've identified this reason, I can just go ahead and put 80 degrees on my diagram, because I know 100 plus 80 makes 180. So I know the angle at the center should be double that. So then once I've written my reason down, I will now go ahead and do 80 multiplied by 2. You want your examiner to have an insight into your thinking process, and that is why I'm always saying think it, ink it, okay? Because we're not able to interact with you. We interact with your cognitive processes based on what you have written. So don't just go ahead and write down 160. Show that you are multiplying by 2. All right, so that gives us 160 degrees, and we have found our answer for y. Well done for making it in this part of the lesson. And I hope that you are understanding how to think, because understanding how to think will close your gaps on applying your knowledge. Okay, so for this series, we're only going to do 3 examples. Okay, so we're going to go into our final rule. Sorry, I meant 3 rules. So rule number 3, again, 2 key vocabulary coming into focus here. So a tangent and a radius meets at 90 degrees. So put that into perspective diagrammatically. So a tangent is a line, we've explored that as well at the beginning, that touches the edge of the circle, but it just touches it on the outside of the circle. And this is why sometimes when I'm teaching and someone seems to be distracted, I will say, you have gone off tangent. You need to get back in the circle. Why do I do this? I'm trying to build the vocab by speaking the language. And you need to speak the language as well. So here is a visualization. I've got a radius here and I've got a tangent on the outside of my circle. Now that creates a perpendicular effect. So remember, perpendicular lines meet at a right angle. So therefore, the angle formed there will be a right angle. Again, cannot stress enough, orientation doesn't matter. So it could be oriented oblique, could be oriented this way as well. So therefore, same principle applies. Again, turn your paper if you have to. So now we're going to go into some examples. In this question, we are asked to find the value of y, and we need to give reasons for our answer. So I look and I'm thinking I need some application here. Now for this question, we're going to need to break it down. I look on my diagram. Some students start writing too quickly without processing their information. Come on, think, man, think. Put some thinking in and ask yourself some questions. Also, listen to the questions your teacher asks when they're teaching. And you need to ask yourself back those questions when you are doing the question. So here, first reason that I'm going to use to unlock this question. If I look clearly, I can see that I have 2 radii. And therefore, the lengths of these 2 sides of the triangle are going to be the same. Clearly, I have an isosceles triangle here, which means that this angle here is 47. The other angle at the base is always going to be 47 as well. So I can simply put that down on my diagram. Also, I need to make sure I write my reason down. Angles at the base of an isosceles triangle are equal. So, with that filled in, and with my theorem that I've just learned, I have now unlocked my question. I've asked to find x, and I can see that x along with 47 degrees will make 90 because the radius and the tangent are perpendicular, which means that they do meet at 90 degrees. So radius and tangents, I'm just going to set up my equation. Therefore, x add 47 has to be equal to 90 degrees. And then I know I need to do the inverse of my operation. Therefore, I'm going to do x will be equal to 90, take away 47 degrees. Again, put that in my calculator quickly. So 90 take away 47 will be equal to 43. So my answer is 4. But I hope that you see the logical thoughts that I've put into this. It really does ensure accuracy, and also it helps you to revise the rules that you have learned. And once you're able to employ that skill, give a clear path for yourself. You will feel less under pressure, and also you are more likely to be accurate, which is what we're after. Now we're going to look at our first example for this rule. So let's look at this question. Here, we are asked to find the value of the angle marked y and give a reason for our answer. Notice I go after my reasons before calculations. So what's the first reason I need to employ? I need to employ the fact that angles on a straight line add to 180 degrees. And that's going to unlock this bit here where I can now find an angle within the triangle that's closer to the one I'm after. So I'm going to write that, let's call this one x. So x at 64 should be equal to 180 degrees. So let's put that in our calculator. We're going to do the inverse, so 180 take away 64 gets us to 116. So x will be equal to 180 degrees, take away 64, and x then will be equal to 116 degrees. I put that in on my diagram to help me close the gaps in the question. Then I look again. I recognize I also have 2 radii here, which is going to now create an isosceles triangle. It simply reasons then that my 2 base angles are identical. So I know that angles within a triangle, so I put that in. Angles in a triangle add up to 180 degrees. Therefore, I'm going to now make an equation. I know that x, if I call this one, let's call this one z to avoid confusion. So I'm just going to scratch that out. So z add z plus 116 should be giving us 180 degrees. Now, we've done in previous lessons how to manipulate algebraic expressions. Therefore, z add z, which remember, there's no coefficient visible, so there's 1. So 1z plus 1z gives us 2z. So 2z at 116 degrees will give us 180 degrees. So now we're going to just do the inverse of our operations. We need to do subtracting 116 from both sides. Put that in our calculator. So 180 degrees take away 116 degrees. That gets us to 64. So we know that 2z is equal to 64 degrees. Now we need the value of 1z because that one is going to unlock our answer for y. So we need to divide this by 2. So 64 divided by 2 is equal to 32. So z is equal to 32 degrees. We put that on our diagram. So I'm just going to fill it here just to make sure you have clarity to see that. So now I can see that my final theorem comes into focus. My next rule will be the one I've just learned, that the angles that are formed when a radius and a chord meets each other is 90 degrees. So you need to write that down. Now I've got the rule in here, but because of the space I've already used, just for clarity, I won't put the rule, I'll just do the working out. So I need to do y then plus 32 will be equal to 90 degrees. Then I need to do 90 take away 32 for my final answer, which is 58 degrees. So y then will be equal to 90 minus 32. I'm putting an arrow here just to say the answer is 58 degrees. And the reason I'm doing that is not mathematically correct to put 2 equal signs in the same sum. Okay, so the final answer here is 58 degrees. Well done for getting through another example on your first theorem. Okay, so now that we have completed 3 theorems, I am absolutely proud of you. And I cannot stress enough, one of the main reasons I'm so proud of you is that the fact that you're here means that you're doing some independent work at home. And that is the key to embedding the skills that you've learned in your class. And so, key takeaways. I'm so excited. I hope you are too. We can see that. So, key takeaways. Rule number 1 that we've discussed today is the angles in a semicircle add to 90 degrees and they must come off the diameter, the 2 ends of the diameter, for that rule to be in force. The second theorem we looked at was the angle at the center is twice the one on the circumference where it hits the circumference. Okay, so remember I said also that there are times when the chord is not visible. You must visualize your chord and draw it in with your pencil so that you can see what you're doing. And finally, we also looked at the radius and the tangent meets at 90 degrees. I hope that I have helped you to stop spinning around in circles and just master your circle theorems. And then once you've known that, just go ahead and apply. And remember, play the video over and over again so that you can get those hidden little nuggets that I've put there for you. And don't forget to hit the notification bell so you know when part 2 of the series is uploaded. Also, remember to share, ask a friend to subscribe, and ensure that they also have the opportunity to learn about these circle theorems.